Okay, so today what we are going to do is we'll talk about situations where uh, individuals or firms are not, price takers. So, like for example, we have discussed one such situation where uh, a monopolist faces the demand curve and it's not a price taker. Okay, so imagine a scenario where there are two such firms, okay, or maybe three such firms which are not price takers. Okay, so how are we going to analyze such a situation? Okay, so we would like to actually propose a framework in which we can not only analyze a situation like this but also situations which are similar to this. Okay, uh, and we'll also propose a solution concept which can be used to predict outcomes in situations like these. Okay, so uh, so we'll talk about game theory. Okay, okay. So let's consider the situation where there are two firms. Okay, so two firms, and they're not price takers. Okay, they faces a demand curve PDQ. So this is a demand curve that uh, that these firms face. Okay, so these firms produce exactly the same product. Okay, and the price at which that they'll end up selling will depend on the quantities that is produced by both the firms. Okay, so obviously the total revenue therefore of each firm not only depends on their quantity choice but also the other firm's quantity choice. Okay, and both firms are aware about this. Okay, and let us say that there is a cost function C1 of firm 1 and C2 of firm 2. So C1 is a function from R plus to R plus, and C2 is also a function from R plus to R plus. Okay, so these are cost functions. So C1 is a function of Q1, okay, and C2 is a function of Q2. Okay, where Q1 is the quantity chosen by firm 1 and Q2 is the quantity chosen by firm 2. Okay. So if Q1 and Q2 are the quantity chosen by firm 1 and firm 2, the price at which they'll end up selling, uh, you know, selling the output will be given by this demand curve. Okay. So what is the price in this case? Price will be, if you just plug in this inverse demand function Q1 plus Q2, you'll get the price. Okay, is that fine? Okay, so we would like to analyze a situation like this, and not just this situation but many situations like these. Okay, this kind of situation, there is a name for it. You can also call it Cournot duopoly model. Okay, so it's a Cournot duopoly model. Is that clear? Okay, and there are other situations, like for example, you can also have another kind of model where there is the firms are not competing in quantities but they are competing in prices. Okay, so that's basically Bertrand duopoly model. So what happens in case of a Bertrand duopoly model? It's a simple model. So I mean, I'm going to consider a simplest possible version of the model for the time being. Okay, obviously, you can have a lot of variations in it. Okay, so in the Bertrand duopoly models, again, the two firms are going to compete, but they will choose the price. Okay, and the firm that is going to get access to the market is the one that chooses the smaller price. Okay, so if there are two firms, let's say one firm chooses price 1.5, other firm chooses price 1.7, then the firm that chooses a price 1.5 uh, will cater to the entire market, and firm that chooses price 1.7 doesn't get to sell any quantity. Okay, so that's the kind of problem that we have in the Bertrand duopoly model. Okay, so we have all these kind of situations. Okay, so I would like to first propose a general framework, to model not just this situation but other situations like this, and then we'll see how we can model different situations in that general framework. So instead of writing it like this, I will specify it in a game form. Okay, all these models. Okay, and then we'll propose a solution concept which is given by Nash. Okay, Nash equilibrium, and we'll then apply basically the Nash equilibrium to all these games. Okay, so basically we'll try and figure out Nash equilibrium of all these games, and see what will be the outcomes. Okay, when we have situations like this. Okay, is that fine? Okay, so let me erase this for the time being. Okay, let me first give you the definition of a game. Okay, and then what I'll do is I'll write all these models in the form of a game. Okay, so the kind of game that I'm going to consider in this class, okay, in today's class, is the one where uh, is the one which is kind of a static game. Okay, so it's a static game, and it's a game of complete information. Okay, so static game of complete information. So basically there is no uncertainty about the payoff, about the utility function, about the payoff matrix. Everything is absolutely clear in this game. Okay, players are going to simultaneously choose their actions, and the payoff will be realized based on the actions that they have chosen. Okay, so that's the kind of setup. Okay, so as I've just told you, you can imagine a Cournot duopoly game where firms are going to simultaneously choose the quantities. Okay, and that's why we are calling it static game. Okay, because we don't have a sequential structure here. Okay, we only have players moving simultaneously. Okay, without knowing what other firm is doing. Okay, so firm one is going to make a move without knowing what other firm is going to do. Similarly, firm two is going to make a move without knowing what firm one is going to do. Okay, and then whatever their actions are, uh, they together determine their payoffs. Is that clear? Okay, so that's the kind of scenario we are in. Is that clear? Is that clear? Okay, so let me first define a game. Okay, static game of complete information. So it's the simplest version of the game. Okay, static game of complete information. Obviously you can have uh, you know games of other types where it's possible that firms don't know each other's cost functions. Okay, or something like that. Okay, or maybe firms are moving in a sequence rather than simultaneously. So we can have lots of variants. Okay, but right now I'm only going to consider a situation where there is a complete information about the demand function, the cost functions. Okay, so both firms know each other's cost function, both firms know each other's basically the demand function. Both firms know everything. Okay, except that they don't know what other firm is going to do. Okay, so that's the only thing that is that will be determined. Okay, that what's going to happen. Okay, so let me propose a general framework first. Okay, so the game consists of what? So game consists of set of players. So this is the definition of the game. Okay, so first we'll have to specify who is playing the game. Okay, so if you recall, in case of Cournot duopoly game, there are two firms, so we can say the set of players in that particular game is 1 and 2. Okay, there are two players. And then the second thing is, we have to specify what are the actions, okay, possible actions that each player can take. Okay, so we are going to call them action sets. Okay, so let's say A1. So let me denote A1 by, so A1 is basically the action set of player 1, A2 is the action set of player 2. So in general, AI is the action set of player I. So if you connect it to Cournot duopoly game, so in Cournot duopoly game, what is the action set? So what is the action set of player 1? Okay, so player 1 can choose any non-negative real quantity. So the action set of player 1 is R plus. Okay, similarly action set of player 2 is R plus. Okay, and if I'm going to put a constraint that firms can only choose integer quantities, non-negative integer quantities, then action set of player 1 will become Z plus. Okay, and action set of player 2 will become Z plus. Okay, and so on and so forth. Okay, so right now I'm just writing the definition of a game for n players. Okay, 1 2 n. Okay, so these are the players, these are the action sets, and what else do we need? Okay, we need the payoffs. Okay, so payoffs or preferences or whatever you want to call that. Okay, so what are the preferences of each player? Okay, so preferences will be modeled by utility function or payoff functions or profit functions, depending on whatever the game is. Okay, so what is the payoff? What is the domain of a payoff function of player 1? The domain will be, so what determines the payoff? It's basically the action of each of the players, right? So if I'm going to, so you can imagine the Cournot duopoly game. So in the Cournot duopoly game, if firm 1 is going to choose Q1, firm 2 is going to choose Q2. Okay, then the payoff will be the profit. Okay, so Q1 is going to come from what? The action set of player 1. Q2 is going to come from what? The action set of player 2. Okay, and once you see those Q1 and Q2, the payoff will be determined by the profit expression. Okay, so which contains both Q1 and Q2. Okay, so so basically utility again is going to be a function of, in exactly the same way, it's going to be a function whose domain will be action set of actions that player 1 can take, set of actions that player 2 can take, set of actions that player n can take. So it's a Cartesian product of these action sets to real line. Okay, and this is not just true for player 1, but it is true for all I. Okay, so it's going to be a function from the action space to real line. Is that okay? Is that fine? So this is the definition of a game. Okay, so this is game. Is that clear? Okay, so now what I'm going to do is I'm going to consider a lot of different type of economic applications. Okay, like for example Cournot duopoly game, Bertrand duopoly game, and I'm going to write it in the form of a game. Okay, so that we have a common structure or common framework to describe all those situations. Okay, so the first thing that I'm going to do is I'm going to describe Cournot duopoly game. So when I'm talking about duopoly, it's two firms. Okay, and if I use the word oligopoly, okay, then it is a general term which is used for any number of firms greater than or equal to 2. Okay, so let me describe the Cournot duopoly game. So if it's a duopoly game, then there are two players. Okay, So set of players is basically two firms. Okay. So let me name them 1 and 2. Okay. Fine. What about the action sets? Okay, so again, as I've told you, this action set is something that can depend, okay, so on the question. So in the question that they'll tell you, what is the set of actions that player 1 can take, what is the set of actions that player 2 can take. So if they specify that player 1 and 2 can only choose integer quantities, then you have to write the action sets accordingly. Okay, if they say that, I mean, if they don't say anything, then by default it is R plus. Okay, so I'm going to go by the default one first. Okay, then obviously you should be careful about, when you read the question, you should pay attention to the details that are given in the question, and then accordingly solve the problem. Okay, so this is the default one. Okay, action sets is A1 is what? R plus, and A2 is what? R plus. Okay, so in the problem, so I'm just telling you that how you can convert all the information that is given to you in the problem in the form of a game. Okay, so that is what I'm doing here. Okay, so preferences in this case will be determined by the profits. Okay, so I'm not going to use UI, I'm going to use pi1. Okay, pi is uh, you know uh, uh, a common notation for profit. Okay, commonly used notation for profit, so I'm going to use that. Okay, so pi1 will be a function from R plus cross R plus, because this is the action set of player 1, this is the action set of player 2, so it's a function from R plus cross R plus to real line. Okay, and similarly pi2 will also be a function from R plus cross R plus to real line. So what are these functions? You have to also write that. Okay, so it's a function of q1 q2. Okay, and then you have to use the information that is given in the problem. Okay, so you have to use the information, all this is going to come from the information that is given in the problem. So in the problem it is given that there are two firms, so this is the set of players. In the problem it is given, or basically, if it is not given, what are the action sets, you're going to take these as default. Okay, R plus. Okay, so again, this will be like implicitly provided in the problem. Okay, and then the final thing is, what is the profit? So profit is something that, again, you'll be given demand function, you'll be given the cost function, so you'll have to write the demand function and the cost function. So because that's what's going to determine the profit. So how do you write that? Well, so q1 times the price at which q1 plus q2 is sold, that's the total revenue, minus the cost. Okay, so this is the profit of firm 1. This is something which is, again, as I've told you, is going to come from the problem. So all this data will come from the problem that is given to you. Okay, similarly you can write profit of firm 2, which is q2 pd q1 plus q2 minus c2 q2. Okay, so this completes the description of the Cournot duopoly game. You can see that it is just a function of q1 and q2. Okay, because this is a function of q1 and q2, this is a function of q1, this is a function of q1, so the entire thing is a function of q1 and q2. Okay, and there is no other thing. Okay, in there. Okay, is that fine? Is that clear? Have you all understood the Cournot duopoly game? Okay, so we have written the Cournot duopoly structure in the form of a game. Okay, similarly, we can write the Bertrand duopoly, problem in the form of a game. So let me write that as well. Bertrand duopoly game. Okay, so again, I'm just restricting myself to two players. Okay, for the time being, I'll just be focusing on two players. Okay, but the ideas can be extended to three players, four players. I mean, that's it's not such a big problem, because I just want to use graphical methods, so I want to restrict myself to two players because it's possible to visualize problems involving two players. For three players, if you have an understanding of two players, then you can actually work with three players easily. If you get a very good understanding of how to solve two-player games, then you can extend these ideas very easily to three players or four players. It's not such a big problem. Okay. uh, so first of all, your focus should be to become really good at solving two-player games. Okay. You have all the apparatus with you. You have seen all the graphical methods. We'll see their applications here as well. And we and we'll see how we can actually use all the techniques that we have learned so far to to solve the games involving two players. Okay. And then of course multiple players. Okay. So set of players is again in this case two. And action sets. So again, by default, the action set will be that firm can choose any non-negative price. Here the firm was choosing quantity, here the firm is choosing price. Okay, so firm can choose any non-negative quantity, non-negative price. Okay, so the default action set is R plus. So again, I'm reminding you that please read the question carefully. In case they don't give you R plus, they say that action set is a set of possible non-negative integers, then you have to use that. Okay, if you start using this in those problems, obviously you are going to make a mistake in finding the solution. So you should be clear about each and everything. Okay. uh, so everything should be taken care of. Okay. And everything will be given in the problem. Okay. So what about the preferences? Again, the preferences will be determined by the profits. So again, profit will be a function from the set of actions that player one can take, then the set of actions that player two can take to real line. Similarly, pi 2 will be a function from r plus cross r plus to real line. Okay. Now, what will be given to you in this problem? Obviously, you'll be given the cost function of each firm. You'll also be given the demand function. Okay. So I'm assuming that in this case, let's, let's use the direct demand function rather than the indirect demand function that you are using here. So in case you are given the indirect demand function, you can always convert it into a direct demand function. That shouldn't be a problem. Okay. So let's say QD is the direct demand function. Okay. So what is the profit? Profit is P pi 1 P1 P2. Okay. And what it is equal to? Okay. So pi 1 P1 P2 will be equal to what? Well, so it depends on who is setting a lower price, right? So if firm one is setting a lower price, then firm one will get access to the entire market. If firm two is setting a lower price, then firm two will get access to the entire market. If they choose to set a same price, then they split the market equally. Again, this is something which I'm assuming right now to write the payoffs, which this is more commonly used tie-breaking rule. Okay. But if the question says otherwise, you have to use that. Okay. So if the question says that if the prices are equal, then firm one gets access to the entire market, then you have to make sure that you have to accommodate that. Okay. So I'm telling you that this is something which is, I would say, like more commonly used model. Okay. But there are variations to it. Okay. And if they if the variations, if the question tells you that use a variation, then use that variation. Okay, don't just say that, okay, I remember this, so I'm only going to do that. Okay, so that's not going to work. Okay, so let me just write the profit. Okay, so this is a case if P1 is less than P2. Okay, so I'm going to write first that case. If P1 is less than P2, then firm 1 gets the entire market. So if firm 1 gets the entire market, then it's going to be P1 times the demand at P1 minus the cost of firm firm 1. Okay, when it chooses to produce, basically when it sets price P1, this is a quantity that firm has to sell, and therefore this is the cost associated with producing this much quantity. So you have to subtract that, and that's going to give you the profit. Okay, and if P1 is equal to P2, okay, then I'm assuming that the tie breaking rule here is that the market will be splitted equally among the two firms. So what that means is that only half of the demand will be met by firm 1, and therefore the cost will be cost associated with half the quantity. Okay, please note that it is not necessarily half the cost. Okay, I'm emphasizing this because don't take this half outside. Okay, it's possible that cost is not a linear function. Okay, through the origin. So if cost is not a linear function through the origin, then taking this half outside will give you a wrong cost. Okay, it's a cost associated with producing half the quantity. Okay, so that's what we are writing. Okay, so this is a function. Okay, it's not C1 times this. Okay, and the last possibility is that if P1 is greater than P2, then you don't get to sell anything. In that case, your profit will be minus C10. Is that clear? Is that clear to everyone? Okay, and similarly you can write the profit of firm 2 in exactly the same way. Okay, so I'm not writing it, you can just do that on your own. Just write pi 2 as a function of P1 P2, and then so if P2 is less than P1, then you have to write a similar expression for P2, and so on and so forth. Okay, so just do that on your own. Okay. Okay, the next is we can imagine a scenario which is a public good contribution game. Okay, so let me first tell you what kind of things that will be, what kind of data that will be provided to you in the problem, and then I'll just write the game, okay, which describes the entire situation. Okay, so you can imagine a scenario. So what is a public good, first of all? Okay, so public good is a good that is non-rival and non-excludable. Okay, so these are the two properties that characterizes public good. Okay, the first is that it's non-rival, and the second is it is non-excludable. Okay, fine. Okay, so what are the examples? Okay, so you can imagine let's say something like defense services. Okay, defense services for the country. Okay, so the expenditure on the defense services by the government is kind of a public good. Okay, the reason is because it's non-rival and non-excludable. So what is non-rival? Non-rival means that if I consume more of something, that doesn't reduce the quantity available to you. Okay, so that's, so if you really think about it, it's like most of the commodities are actually rival. Let's say, for example, if there are 10 units of chocolates and I consume 6 units of chocolates, then what is available to you will be just 4 units of chocolates. Okay, so if you see in the Edgeworth box, commodities are rival in nature. Is that okay? Yes. Okay, so there is a rivalry. Okay, so that rivalry will not be there in case of public good. So in case of public good, so if I get to consume more, everyone else also gets to consume more. Okay, so you can imagine a scenario like non-rivalry is like, let's say, for example, if I decide to teach more in these classes, then it's not that I only decide to teach one of you. Okay, it's something that is applicable to all of you. Okay, so my teaching is kind of non-rival in that sense. Is that clear? Okay, so if you choose to take more of my lectures, then everyone else will also get more of my lectures. Okay, in this class, of course. Is that clear? Have you understood this? Okay, and all these public goods will fall into this category. Okay, public goods means the goods that are provided by the government. So it's better infrastructure, investment in let's say cleaning the city, or cleaning the rivers, so all these expenses will fall into this category, that they are non-rival, because it's just going to benefit all the people. Okay, and if one person gets more of it, that is not going to reduce its quantity available to the others. Okay, so is that clear? Okay, and you can also imagine a setup like, as I've just told you, in these classes. Okay, so if, let's say, the in our little scenario where only us are there, only me and all of you. Okay, you can imagine that in this scenario, my teaching is like a public is like a non-rival commodity, because as I've just told you that it's if more of uh, my lectures are available to someone, then it is also available to everyone. Okay, so that's non-rivalry. Okay, so again, it totally depends on the scenario. Okay, non-rivalry, the nature of non-rivalry in certain cases can change, if the scenario changes. Okay, so in our scenario, okay, like defense, or for example, those kind of goods, of course they are non-rival. Okay, um, uh, yeah, so okay, let me also talk about non-excludable. So non-excludable is basically when you can exclude someone, okay, from basically consuming something. Again, you can imagine that defense services, if the government decides to spend more on defense, then it cannot exclude any one person who is living inside the country to get the benefits of those services, right? I mean, it cannot exclude anyone. Do you agree that if it decides to spend more on defense, then everybody will be reaping the benefits of that extra expenditure? Basically, they might feel more protected, whatever. Okay, so the key thing is that most of these government services, the kind of services that the government provides, fall into this category, public good. Is that okay? So have you understood the difference between non-rival and non-excludable? Let me talk about my lectures. Okay, so my lectures are excludable. Okay, so why are they excludable? Because I can always choose that some people don't attend my lectures. Okay, so people who are not joining these classes, don't have access to these lectures. Okay, however, my YouTube videos, they are both non-rival and non-excludable. So if I post something on YouTube, that's non-rival as well as non-excludable, because I cannot exclude anyone from watching those videos. Okay, and I cannot so if somebody else is watching my videos, that doesn't reduce its availability to someone else. So my YouTube videos is actually public good. Okay, but my lectures, which are exclusively for you, they are non-rival. Okay, but they are excludable. Okay, excludable because they are only accessible to some set of people. Okay, the people who are enrolled in this class. Is that clear to everyone? Have you all understood this? Okay. Okay. So if you restrict, if you restrict uh, the society to only the set of students who are in my class, okay, so if you restrict that, okay, nobody who is outside my class is considered part of the society, okay, then in this little society, my lectures are public good. Okay, because nobody can exclude someone else from attending my lectures. Is that clear to everyone? Okay, so they are non-rival and non-excludable. So it totally, as I've just told you, it totally depends on the context. Okay, so if in the problem, so from the problem you have to make out whether it's a public good or not. Okay, I mean, sometimes they give you that it's a public good, sometimes you just have to make it up. Okay, whether it's a public good or not. Okay, uh, so as I've just told you, if I restrict the society to only the set of students in my class, then my classes are both non-rival as well as non-excludable. Okay, like the YouTube videos. Is that fine? Okay, but if I consider the entire world as a society, then in that society my lectures are non-rival, but they are excludable. Is that fine? Okay. Okay, so let us consider a very simple scenario, okay, where uh, where let's say there are two roommates. Okay, so the society consists of just these two roommates. So you can imagine that there are two roommates. Okay, and they are interested in basically buying some utility for the room. Okay, so they share a room. Okay, and they want to buy some utility. Of course, once that utility is bought, it will be used by both. So it is like a public good when it comes to these two roommates. Is that clear? Okay, so they are interested in buying some utility. You can imagine that they are interested in buying a television or something like that. Is that fine? Okay, understood. Okay, so what they're going to do is this, that they are going to contribute out of their pocket money. They are going to contribute something. Okay, so suppose individual 1 has pocket money M1, individual 2 has pocket money M2. Okay, so individual 1 is going to contribute some amount. Okay, is going to contribute C1. Okay, C1 out of it, and individual 2 is going to contribute C2 out of it. Okay, and then from this contribution, C1 plus C2, okay, they are going to get a public good. Okay, so or basically a utility. Okay, a utility or a service or a television, whatever you want to call it. Let's say this is a function f, which will determine, so if it's, let's say, television, you can say that this is the kind of television that they're going to get. So higher the contribution, the better the uh, the better, maybe the bigger the size of the television, or you can say, uh, you know, more features will be there in the television. So you can say this is like kind of a features function. Okay, so higher the total contribution that you're going to put in, the more features you're going to get. Okay, and of course, the more features you're going to get, the higher the satisfaction level that you're going to get. Okay, so let's assume that there is a utility function u, okay, which is a function of the contributions. Okay, so you can say that it's a function of what kind of television that you're using. Okay, so you can say that it's v1 of f c1 plus c2, and the remaining pocket money. Okay, and similarly u2 c1 c2 is a function of c2 f c1 c2 plus m2 minus c2. Is that okay? So this is a feature, and this is how the feature gets converted into the utility. Okay, this v function will do that, and plus m2 minus c2 is basically whatever is his remaining amount after contributing c2 to the public good. Okay, so you can consider these kind of utilities. Okay, these are also known as quasi-linear utilities. Okay, so why are these quasi-linear? Because if you really think about it, it's v1 of g plus whatever is the money, okay, that he's consuming. Okay, you can call that x. So it's actually a function of v1, which is a function of the public good, plus x, okay, which is, so here g is basically this, okay, and x is this. Okay, so x is amount that he gets to consume, and g is basically the public good that he gets to consume. So you can see that his utility is actually, if you write the utility in terms of goods, right, utility is a function of the commodities that you're consuming, then it is v1 g plus x, and that's quasi-linear, right? Yes or no? Okay, and that is why you call this quasi-linear. Is that clear to everyone? Okay. Okay, so now we are in a position to basically describe this game, okay, where there are two players and they are going to contribute for the public good. So again, the game consists of set of players. So in this case, the players are these two players who are going to contribute to the public good. Okay, and action sets, well, players cannot contribute more than their pocket money. So we are going to say that A1 is 0 to M1. It's a closed interval, 0 to M1. And A2 is 0 to M2. Is that okay? Fine. And then you have the payoffs or the preferences, okay, which are given by, so utility, okay, U1, which is a function of the contribution of player 1 and player 2, okay, which is equal to what? V1 F C1 plus C2, okay, plus M1 minus C1, and U2 C1 C2 is V2 F C1 plus C2 plus M2 minus C2. Okay, again, I'm giving you a commonly used framework, okay, but it's possible that the payoff function might look something different from this, and if that happens, then you have to use those. Okay, but this information will be given to you in the problem. You will be given that the utility is a function of public good and the amount of money left. Okay, so this is the kind of utility function that might be given to you. Okay, and then you are also given that how is G connected to the contribution. So if the contribution is C1 plus C2, then G is f of C1 plus C2. Okay, so all this kind of information might be given, and from this kind of information you'll have to write uh, this in terms of contributions, because you need to write the utilities as a function of contributions, because that's what you are choosing. Okay, and that's what each player is choosing. So you have to convert this information into this, and then you have to uh, you know uh, basically apply the solution concept to solve this game. Okay, so okay, fine, so let's now move on. Okay, and we can also have other game. Okay, so you can actually think of in fact, I posted many such games today on Piazza. Okay, so you can actually write those yourself. Let me give you one more, and then and then I'll move on to how to solve these games. Okay, uh, so you can imagine a scenario. So let me take a different version. Okay, different setup where uh, different than the ones that I've given you on Piazza. Okay, so let's think of the effort contribution game. Okay, so where you're going to put some effort in typing answers on Piazza. Okay, and what value it generates. Okay, so it's kind of so let me just write it. Okay, so Piazza contribution. Okay, so it's basically the game amongst all of you. Okay, where everyone is going to choose some effort. Okay, and once everyone is going to choose some effort, then so like for example, let's say the answer. Suppose you know the answer to a particular question, then you have to put in some effort to type that answer and post it on Piazza. Okay, so obviously the person who is posting and posting putting that effort to post that answer on Piazza, if he knows the answer, he doesn't benefit a lot from it, because it's basically for the others to see. There is a possibility that he might benefit, let's say if he needs an input from the instructor. Okay, so that's a small benefit that he can have. But let's say if he knows the answer for sure, okay, then there is little benefit in posting it on Piazza, right? Okay, is that fine? Okay, so we would like to analyze this scenario. Okay, and we would like to model it as a game. Okay, and then we would like to predict what will happen. Okay, is that fine? Okay, so Piazza contribution, we have set of n players. Okay, so basically this class is a set of players. Okay, the action sets are basically the effort. Okay, fine. So the effort levels, you can just say that they are again, you can just quantify them as non-negative real numbers. Okay, so the higher the effort, the higher the cost of the effort. Okay, so efforts are chosen from R plus. Okay, so A1 is R plus, so AI is R plus basically. Okay, and what are the preferences? So how do we write the preferences? Well, you can say that you'll prefer if other people are putting in effort, okay, and obviously your effort will only cost you something, okay. So you can imagine, how do you write this kind of payoff function? You can say that u1 is a function of e1 e2 to en, okay, and it is equal to, okay, the value that you derive from others effort, okay. So we can say that, let's just consider something like this, e2. So it's a utility function of 1. It's a function of e2 plus e3 plus en, okay. So if you want, you can put some v around it, okay. So it's some function of the sum of the efforts of the other people minus the cost of your effort. Is that okay? Okay, and you can put a 1 here so that people can have different value function and different cost functions, okay. And you can basically write this as, for any ith player, you can write it as ui is a function of effort of player I and effort of players other than player I. So how do you write e? So what is e minus I? E minus I is basically, so what is e minus 1? E minus 1 is nothing but e2 to en, okay. And what is e minus 2? So basically it's the effort of all others except player I, okay. So you can just summarize it in this way, okay. So ui is a function of ei and e minus I, okay, where vi, okay, depends on summation ej j not equal to I minus ci ei. Is that clear? Okay, so that's how you can write the payoff of player I. Okay, so this is utility of player I basically. Okay. Is that clear to everyone? Is that clear to everyone? Okay, so we would also like to analyze what will happen, in a scenario like this. Okay, and of course there are other problems, which I've posted. You can have a scenario where there is an auction, first prize auction, second prize auction. You can also have a scenario where, let's say, people are going to a restaurant deciding whether they want to split the bill or they want to pay their own bill. So you can have many scenarios which you can model, using this, and I have posted many questions like that on Piazza. So hopefully, after this lecture is over, you will be able to attempt those questions. Okay. Okay, so now let me propose the solution concept, okay, that we are going to use to predict what will happen in the scenario, in these scenarios.